Welcome to today's session on standard form. Now, some of you may have used standard form, or some of you may know it as a scientific notation. This is just a way of being able to represent very large numbers or very small numbers in a more simplified way. It works on the base of base 10 with our rules of indices. So, for example, I've got 1.6 million. I can represent this in the standard form as 1.6 times 10 to the power of 6. Now, anytime that we're dealing with standard form, we'll always have one actual unit number, which will be anything between 1 and 9. No less than 1, so never have 0 point. There'll always be a full number all the way up till 9, so no bigger than 9. So 10, 11, that won't happen. Anything between 1 and 9. We could have a decimal point with some numbers after this. The 1.6 from our number just here comes from our 1.6 million, our 1,600,000. It'll be always multiplied by 10 to a power. Now, a nice way of working out what this power of 6 is that from our 1, which is going to be before the decimal point, we count how many numbers there are after it. So 1, 2, 3, 4, 5, 6. So it's going to be to the power of 6. A way of representing this is that you've got starting off with my 1.6, and I'm going to first of all multiply it by 10. So all of my numbers move to the left by 1 place value, multiplying it by another 10, by another 10, and so on and so forth until I reach to the power of 6, which is my 1,600,000, which I've actually got in my question. So that's exactly where my standard form comes from. But we can also use it with very small numbers, not just very large numbers. But for these, the powers, above the power 10, above the base value of 10 will be a negative number. So here I've got 0.0006, and I can represent that as 6 times 10 to the power of -4. So my first number is going to be my number furthest to the left, my first whole number furthest to the left. In this case it's 6 times 10 to the power of -4. So again, another way of getting this, to get from our unit number to our first number, I'm going to come back 1, 2, 3, 4, and because we are going into our decimals, it's going to be a -4. Again, going to show that how that comes about. So here I've got 6. If I divide that by 10, or 10 to the power of -1, this is going to be 0.6, and so on and so forth until we reach 0.0006, which is what we've got in our example, which is dividing by 10 to the power of 4 or multiplying by 10 to the power of -4. So we can add and subtract anytime that we're dealing with standard form. So here I've got 6 times 10 to the power of 4 plus 4 times 10 to the power of 3. Now some people like to actually write these numbers out completely. So if I was to write my 6 times 10 to the power of 4, that will be 60,000. And my 4 times 10 to the power of 3, that's going to be 4,000. Adding these together will be 64,000. But anytime that we get a question like this, normally it asks us to leave our answer in standard form. So we've got to convert this into standard form. So we are going to start off with 6.4, and after the 6 we're going to count how many numbers we've got. We've got 1, 2, 3, 4. So it's going to be 6.4 times 10 to the power of 4. Now we can automatically add or subtract questions like this by making the indices equal. By that I mean, if I was to reduce my 6 times 10 to the power of 4, reduce that power down to 3, which means that I'll be moving my 6 one place value to the left, which would make it 60, I could add these straight across. So what I'm going to end up with is 60 plus 4, which is 64 times 10 to the power 3. And now I'm going to be looking to put it back into proper standard form. So my 64 is going to move to the right by one place value to make it 6.4, and by doing so I've got to add another power of 10 to my power. So it'll be 6.4 times 10 to the power 4, which is exactly what we got from writing out the full numbers, writing the numbers out in full worded numbers and then adding them through. Just showing that this works for subtraction also. So for this, I'm just using the method that we showed at the bottom here. So making our powers equal. So 60 minus 4, that gives me 56 times 10 to the power 3, and then moving my 56 to the right by one place value, which gives me my 5.6, and then adding a power to my 10 to the power 3, which gives me times 10 to the power 4. We can also multiply and divide with standard form using our laws of indices. So these are the two laws that we're going to use when we've got a base value to a power, multiplying by the same base value to a power. We can use that same base value and just add together our powers, and when we're dividing we subtract our powers. So I've got two examples here, one multiplying, one dividing. So I'm just going to work our way through these. So here I've got 6 times 4, which I'm going to deal with first. My 6 times 4 gives me 24. And now I'm going to deal with my powers. So 10 to the power 4 times 10 to the power 6. Sorry, 10 to the power 2. That's going to give me the same base number, which is 10. And adding our powers together, 4 plus 2, that gives me 6. So 10 to the power 6. Bringing these two together, 24 times 10 to the power 6. And now I have to move my 24 across one place value to the right to put it into standard form, and I'm going to add a power to my 10. So this becomes 2.4 times 10 to the power 7. With dividing, I'm going to first of all divide my numbers. So 6 divided by 4, that gives me 1.5. And my 10 to the power 4 divided by 10 to the power 2, that's going to be 10 to the power 2, because my 4 subtract 2 gives me 2. Bringing these together, I've got 1.5 times 10 to the power 2. I haven't got to do anything to this, it's already in standard form because I've got a unit number, which is between 1 and 9, and I've got a decimal which I've included in this answer as well. So it's 1.5 times 10 to the power 2. And that's how to multiply and divide with standard form. And thank you very much for watching.